8.3 scientific notation. We have scientific notation, which is kind of a shorthand way for writing very large and very small numbers. We can write any kind of numbers in scientific notation, but usually it's reserved for very large or very small numbers. Standard notation is the way that we normally write numbers. Scientific notation is in this form. A number times, now x means times in scientific notation. It's not a variable like it is in math class. 10 to some number, where n is an integer. That means it's a whole number, positive or negative. And a has to be between 1 and 10. Now, see this bar right here? What does that mean about a? It can equal 1. Can a equal 10? No, but it could be 9.99999, but it cannot equal 10. So basically, a has to be a one-digit number. Here's some information that we'll go over in just a little bit. And with scientific notation, it's okay to have negative exponents in the final answer. What we've done so far, we haven't left any negative exponents, but with scientific notation, it's okay. In scientific notation, numbers less than 1 use negative exponents. So that's how we represent those numbers, those small decimal numbers. They have negative exponents. A bunch of these are worked out on your notes, so look up there and pay attention. It says write in scientific notation. So we're going to take this number, 405,800, and we're going to write it in scientific notation. Now remember that first number that we write down has to be between 1 and 10. It cannot be 10. So I'm going to write down the number 4.058. Now, you see where I got those digits? I moved the decimal, exactly. Now, what we're going to do to make the number equal, we want the same number, we just want it to look a little differently, is we're going to multiply by 10. What happens when you multiply by 10? What happens to that decimal place? It goes to the right one, doesn't it? Okay, so if I multiply by 10, I would get 40.58. If I multiply by 10 again, I would get 405.8. If I multiply by 10 again, etc. So we want to see how many places did we move the decimal. Well, we moved it from here over to here. So how many places did we move the decimal? 5 places. So that's how many times we multiply by 10. So 4.05 times 10 to the 5. It makes sense. That's good. It makes sense. Okay, on part B, what number am I going to choose to write down? Remember, A has to be between 1 and 10. I'm going to write down what? 1.35, exactly, times 10 to the something. Now move the decimal place from here over to here. So how many places did I move it? 3, 6, 9. So times 10 to the 9. Now notice these numbers that we're doing right now are numbers larger than 1, and the exponents are positive numbers. Larger than 1 and the exponents are positive numbers. On the next two numbers, these numbers are smaller than 1, so they're going to have negative exponents. So what number am I going to write down first? 5.7. 5.7. Now move the decimal place from here to right there. Times 10 to the, how many places did I move it? 3 places, and it's going to be negative 3. Now if you think about what we've learned with negative exponents, what does that mean when it's a negative exponent? It really should be on the bottom, right? And if 10 is on the bottom, instead of multiplying, I'm doing what? Dividing by 10. So if I divided by 10 3 times, that's where that little small number less than 1 would come from. Okay, let's do the next one. What's the first number we're going to write down? Very good, 6.27 times 10 to the something. And I know it's going to be a negative exponent because it's a number less than 1. So I'm I'll move the decimal from here to here. And yes, -6. Okay? Now we're going to go the other way. We're going to go from scientific notation to standard notation. Remember, these that have a negative exponent are going to be a number smaller than 1. The ones that have the positive exponent are going to be a number bigger than 1. So this 4 tells me I'm going to move the decimal 4 places to make the number smaller than 1. Right, so I'm going to put point. Now, do I put 4 zeros? How many zeros do I put? 3 zeros, and then 2, 6, 5. Okay, so notice I moved the decimal from here to there. That's your 4 places. This time I need to move 7 places. So how many zeros do I write down? 6. 1, 2, 3, 4, 5, 6. And then what? 3, 8, 6, 7. Very good. On these last two, the exponent is positive, which means we want to move the decimal so that the numbers are greater than 1. So this time, instead of moving the decimal to the left to make a small number, we're going to move the decimal to the right to make a large number. Okay, so we're going to write 5, 7, and how many zeros? 4 zeros? 3 zeros. 1, 2, 3. On part D, we're going to move 2 spaces. Which way? What's my number? 0.05? To the right. 530.1. Now, it gets confusing when you start thinking about moving left and moving right, because on the scientific to standard, you move one way, and from standard to scientific, you move the other way to do the exact same thing. So what helps me the most is to think about if the number is greater than 1 or less than 1. And then if it has a positive exponent, the number is going to be bigger than 1. So move the decimal the direction that makes the number bigger than 1. All right, let's look at number 13. We're going to do a couple of these by hand, and then we're going to start using the calculator. We're going to put our like bases together. So we have 3 times 5. Remember, the x's mean times when we're doing scientific notation. 3 times 5 is 15. Then we're going to bring down times 10 to the -6. We want our answers in scientific notation. Is this scientific notation that I have? No. What's wrong with this? Exactly. This 15 is not less than 10. This number right here has to be less than 10. So what I'm going to do next is I'm going to change this number to scientific notation. Ignore this for a minute. 1.5, exactly. 1.5 times 10 to the 1. And now, oh yeah, now we're going to bring this part down. Times 10 to the -6. Now we're going to put our like bases together. Okay, so now we're going to put our like bases together. So we're going to have 1.5 times 10 to the -5. Very good. Very good. Okay, let's do the next one on the calculator. You can type this into the calculator and it will give you an answer in scientific notation. However, you have to tell the calculator that you want the answer in scientific notation. So I want you to press the mode button. Mode. At the very top of the screen it says normal and it says SCI right next to it. That means scientific notation is what that means. So move the box over 1 space and press enter so that the box sticks. Okay, so we're in scientific mode, which means every answer that the calculator gives us is going to give us in scientific notation mode. Let's do this first one right here that we already did by hand. So if we did 3 times 5 your exponent button, and your exponent's -6, and then press enter. Now look what it tells you. It gives you kind of a shorthand notation for the answer. 1.5e -5. Now look at that on the calculator and look what we got by hand. If you write down 1.5e -5 on any worksheet or test, I'm going to mark it wrong. Do you see how you convert this 1.5e -5 to 1.5 right? That's the exponent for the 10. So we're going to do part B on the calculator. Let's do that. Okay, so we're going to have 5 times 7 times 10, exponent button, -3, enter. Okay, now we're not going to write 3.5e -2. Write 3.5 times 10 to the what? -2. Very good. And remember scientific notation, it's okay to have negative exponents. Now all of these at the top we can do on the calculator too. Let me go ahead and show you that. For instance, problem number 1, part A, if we just type in 405,800, now we have to make sure we're in scientific mode. But once you're in scientific mode, you can just press in a number and hit enter, and notice it gives you the scientific notation form of that answer. Let's do part C. 0.7 times 0.4 times 10 exponent 5. Enter. And what do we get? 2.8 times 10 to the what? 4. Very good. And part D, 4 times 3 times 10 exponent 4. Very good. 1.2 times 10 to the 5. Now let's try some of these on example 12. Now what you have to do on example 12, we want the answer in standard notation. So that means I have to go back to mode. Everybody press the mode button. And I want it back normal. I want it to give me normal answers. So press the enter button for normal. Now if I type in the scientific notation form, it should give me the normal form. Now, if the number is really, really tiny, it's going to keep it in scientific notation at 2.5 times 10 exponent -4. Enter. Okay, do you see what happened on that one? When the number is small, it's going to leave it in scientific notation no matter what. Even if you look on mode again, are we in the right mode? Yes. But let's look at C. Let's type in part C. 5.7 times 10 exponent 4, enter, and it gives us the standard notation problem. So you do have to know how to do these because the calculator can't do all of them for you. All right, let's look at the last two examples. Now these especially we can do on the calculator. We're going to do this first one I'm going to show you by hand. We're going to put our like bases together. So what do we do when we're dividing? We just went over, we're going to subtract. So you would divide 8.5 divided by 1.7. 8.5 divided by 1.7. And you get 5 times 10 to the. Now our exponents are 5 and 8. So we're going to say 5 minus 8, which is what? -3. And there's your answer. Now let's type this one into the calculator. You need to be sure and use your alpha y equals and your fraction. And we need to be in scientific notation mode. Let's press the mode button and get in scientific notation mode. Okay. So 5 times 10 with an exponent of 12. And then on the bottom, we need 10 times 10 with an exponent of 4. And that's all we need on there, so we're going to press enter, and it should give us the answer in scientific notation because we put it in the correct mode. So how do we write that down? 5 times 10 to the 7. So be sure you use your alpha F1 on that. Now, number 15 on the test is going to be a word problem, and I'm going to show you the clues in the words that's going to help you get this right. On part A, notice I've underlined and bolded a word probability. Probability, and then on part B, I've underlined and highlighted the word per. What does the word per mean in that? He paid $3 per gallon for gas, each one. So how could I figure that out if I bought 10 gallons of gas? Multiply, exactly. So this one that says per is going to be the multiply problem. What is probability? Divide, exactly. So there's your clue for getting these problems right. In a certain country, the population is 4.4 million people. Now, million is times 10 to the 6, in case you didn't know. 27,500 people have formed a new political party. If a person is picked at random, what is the probability the person belongs to the new political party? So we're going to take the 27,500 and divide it exactly by 4.4 times 10 to the 6. Okay, so let's make sure we're in the right mode, scientific. Alpha y equals 27500 on the top, 4.4 times 10 exponent 6 on the bottom. Very good. Equals 6.25 times 10 to the negative 3. That's not a very big chance, you're right. And the last one, we are a large trucking company. We have 9.6 million loads. Now remember, million, you can exchange the word million with times 10 to the 6. Million is 6 zeros, so it's times 10 to the 6. At an average value of $30,000 per load, what is the total value of the goods delivered? So we've got the $30,000 per load times the 9.6 times 10 to the 6. We're in scientific mode, and we just have to press that on the calculator screen. 30,000 times 9.6 times 10 exponent 6 equals 2.88 times 10 to the 11. That's a lot, isn't it?